lecture. Okay, evaluating investment funds. Okay, this is under topic 5, cash flows. Okay, so when you want to evaluate an investment proposal by a to use, okay, many companies use these 7 methods to evaluate whether they should invest in an investment proposal or not. So among the methods are, method 1 is payback period method. I won't be going into all these methods. It's just to let you know that there are so many methods. Method number 2 is accounting rate of return method. Method 3, net present value. 4 is internal rate of return method. 5, profitability index method. 6, discounted paycheck period method. 7, adjusted present value method. Okay, so there's 7 methods here. Okay, the most popular method here is the net present value method, which we are going to look at. Okay, net present value and internal rate of return method. These are the only 2 methods that you need to study in this course. Okay, so this course will focus on these 2. Today we'll focus on these 2 methods only. Okay. Okay, which fund to invest in? When you want to invest in a fund, there are a lot of things that you must look into. Okay, so the first thing that you're going to do is you're going to evaluate the fund. Okay, so how are we going to evaluate the fund? We're going to use 2 important approaches. That is the net present value, also known as the NPV method, or the internal rate of return, IRR method. Okay, so both these methods use a discounted cash flow model to assist with the process. Okay, the net present value method and the internal rate of return are 2 commonly used time value of money based options. Time value of money means that they consider the money that you have now and how much it will be in the future, or the money that you get in your future, how much is the value now. That is what they mean by time value of money. Any model that takes this into consideration is a cash flow model or time value of money based model. Okay, both of these methods are based on the discounted cash flow process. When we use the word discounted, means that we are always looking at the present value. Okay, from the future value we discount to the present value. So discounted method means finding the present value method. Okay. Both of these measurements are primarily used to determine whether a new investment will generate net economic profit or losses for the company. So we're going to use NPV and IRR to see whether the new investment is profitable or not. Okay. Both the models have their own pros and cons. So which tool is better, we will see later. Okay. Okay. So the first method that we're going to look at is net present value. Okay. Net present value is the difference between the present value of cash inflows and the present value of cash outflows over a period of time. Okay, what you put into the investment, okay, the money that you put into the investment, you are spending that money, okay, and the belanjakan wang itu. So that money is known as the cash outflows. The money that you get from your investment over a number of years, that is known as the cash inflow. Inflow means money coming in. Outflow means money going out. Okay, so net present value is the difference between present value of cash inflows and present value of cash outflows. Okay, over a period of time. Okay, the important keyword here is present value. That means you must calculate the present value for all the money. Okay. The discounting technique converts cash inflows and outflows for different years into their respective values at the same point of time, allows for time value of money. Okay. This method is particularly useful for the selection of mutually exclusive projects. If there are mutually exclusive projects, what do we mean by mutually exclusive? That means, say there are two projects, projects A and B. Mutually exclusive means if you choose project A, you cannot choose project B. If you choose project B, you cannot choose project A. They are mutually exclusive. You can only choose one that is mutually exclusive. Okay. So this method is very good for mutually exclusive projects. How to choose between project A and project B. Okay. NPV analysis is used to determine how much an investment, a project, or a series of cash flows is worth. You want to find the worth in terms of money. Yeah? It is an all-encompassing metric as it takes into account all revenues. Revenues is money coming in, expenses is money going out, capital cost is money going out, associated with an investment in its cash flow model. In addition to factoring all revenues and costs, it also takes into account the timing of each cash flow that can result in a large impact on the present value of an investment. Okay, this is just a little bit of background. Okay, decisions from NPV. Once you calculate the NPV, what do you do? Okay, if the yield is positive, if whatever money that you get, the amount that you get, okay, that's the yield. If it is positive, that means the project is acceptable. In other words, if NPV is greater than zero, okay, anything more than zero is positive, then you can accept the project. This will show the additional value to your wealth. If it is negative, okay, it means that the project is unable to pay for itself and is thus unacceptable. That means if NPV is less than zero, anything less than zero is negative. So if it's negative, then you must not accept the project. It will bring you losses. Okay. So the exercise involved in calculating the present value is known as discounting. Okay, and the factors by which we have multiplied the cash flows are known as discount factors. Okay. So to go back, the most important thing that you have to know here is this, okay? The net present value is the difference between the present value of cash inflows and the present value of cash outflows over a period of time. That means all the cash inflows, you collect it all together and minus the cash outflow. That is the net present value. Okay, later we will see how to calculate. Okay, now we look at internal rate of return, IRR, okay? The internal rate of return is a calculation used to estimate the profitability of potential investments, okay? Just like NPV. Okay? The internal rate of return refers to the percentage rate of return, which is expected to be created by the project. That means when you calculate internal rate of return, your answer is in the form of a percentage. Internal rate of return means interest. Okay, it's interest. So your answer is the form of percentage. But NPV is the difference between the cash inflows and cash outflows. So NPV, your answer is in the form of ringgit, how much of money. But internal rate of return, your answer is in the form of percentage. That is the main difference, okay? So the internal rate of return is the discount rate, okay? It's the discount rate at which the net present value of an investment is equal to zero. That means you are finding the discount rate when the cash inflow minus the cash outflows is zero, or In other words, you're finding the discount rate when the cash inflows is exactly the same as the cash outflow. Okay, what you put inside and what you gain and what you get later is exactly the same. Okay, so you want to find the discount when that happens. Put another way, it is the compound annual return an investor expects to earn over the life of an investment. Life of an investment means sometimes the investment only lasts for a few months. So that is the life of the investment. Sometimes you do a project only for say 5 years. After that, no more already. The whole project stop. So the life of the investment is 5 years. Okay, that is what you mean by life of the investment. Okay. The internal rate of return is a way of expressing the value of the project in a percentage instead of in a dollar or ringgit amount. The internal rate of return is the discount rate that makes the present value of the project's cash inflows equal the initial investment. Okay, so you find the discount rate when the project's cash inflows equal the initial investment. This also means that cash inflows minus the initial investment is equals to 0. Okay. Okay. Decision rules for IRR. After you calculate IRR, what do you do with the value? Okay. If the IRR of a project is greater than or equal to the project's cost of capital, in other words, is the discount rate. Okay. If the value that you calculate for IRR, if it's greater than the discount rate or if it's equal to the discount rate, then you can accept the project. Okay? But if the IRR is less than the project's discount rate or cost of capital, reject the project. The rationale is that you never want to take on a project for your company that returns less money than you can pay to borrow money. Okay. Okay, just as with net present value, you have to consider whether you're looking at an independent or mutually exclusive project. For independent projects, if the IRR is greater than the cost of capital, then you accept. For independent projects, say you have 3 projects, A, B, and C, okay? If project A, you calculate the IRR is greater than the discount rate, you can accept project A. Project B, if you calculate the IRR and it is greater than the discount rate, you can accept it. Project C, if it's greater, you accept it. If it's not greater, you don't accept it. That's all. That's independent. Independent means whether or not you accept one project doesn't matter whether if you reject the other projects, okay? But mutually exclusive project means you must compare the 2 projects. You can only take one, okay? If you take this, you can't take the other one. If you take the other one, you can't take this. That is mutually exclusive projects, okay? Okay. If there is more than one viable option, the company will select the alternative with the highest IRR. Okay, if you've got more than one project and you've calculated the IRR and you only can choose one, then the company will choose the highest IRR that exceeds the expected rate of return. Okay, just comparing a little bit between NPV and IRR. Okay, NPV is the value of all future cash flows throughout a project's life cycle. When they say the value of all future cash flows, positive and negative, okay, that all we can say like this, or we can say it is the value of cash inflows minus cash outflows. Okay, we can say NPV is this, okay, or we can say NPV is the value of all future cash flows. That means positive and negative. That means if your cash, if you're paying money, it becomes negative. Okay, negative. If you're receiving money, it becomes positive. When you add all together, it is still the same. These two is the same actually. Okay. Okay. IRR is the discount rate at which net present value of an investment is 0. This is the difference between NPV and IRR, okay? NPV, you find the difference between cash inflows and outflows. IRR, you set the NPV to 0 and you find at what discount rate the NPV is 0. That means there is no difference between the cash inflows and the cash outflows. Okay. Project managers prefer to use NPV because it is considered the best when ranking mutually exclusive projects. But businessmen, they prefer IRR because IRR gives you the value in terms of percentage. Straight away they know, okay, rate of return 20%. They know 20% means what, so they prefer. Okay, but project managers prefer to see it in terms of money. If you want to see it in terms of money, then you calculate NPV. Okay, both of these measurements are primarily used to determine whether a new investment will generate net economic profit or losses for the company. Okay. With NPV, proposals are usually accepted if they have a net positive value, while IRR is often accepted if the resulting IRR has a higher value compared to the existing cutoff rate. Okay. Projects with a positive net present value usually show a higher internal rate of return greater than the base value. Usually, when you for one project, when you calculate both the NPV and the IRR, usually if the NPV is positive, the IRR is also high. So it's easy to make a decision. But sometimes you get opposite values, okay? Then those times it will be very difficult to make the decision. Okay. Okay. NPV is much more reliable when compared to IRR and is the best approach when ranking projects that are mutually exclusive. Actually, NPV is considered the best criterion when ranking investments. Okay, so if you have a choice, you want to use NPV or IRR, then NPV is the better method. It is the more widely used method because calculating IRR is a little bit difficult, okay? Okay, how to calculate NPV, okay? First, for each amount, whether it's coming in or going out, you have to find the present value, okay? So NPV means net present value. Therefore, you must calculate the present value for all cash flows, okay? Then add the present values you receive, total it all together, okay? Subtract the present values you pay. That means all the present values you receive, any money that you receive, this is known as cash inflow, okay? Money coming in is money that you receive, okay? You pay means money is going out. Money going out is cash outflow, okay? So add all the money that is coming in, not the money, but the present value of the money that's coming in minus the present value that you pay. Okay, that is the net difference. Okay, in other words, NPV is okay. So supposing you have a model like this. Okay, let's draw our cash flow model. Say this is year. This is in years. Okay, so you have year 0, 1, 2, 3, and so on. Year 0 is now. Okay, it's present time now. Okay, so here is where you make your investment. This is your investment. How much of money you want to put into the investment. Say after 1 year, you get some money. This is cash flow 1. Okay, after the second year, you get some money. This is cash flow 2. After the third year, you get some money. This is cash flow 3. This is coming in. All this is inflow. Okay, CF1, CF2, CF3 is inflow. XO is outflow because you are paying. When you put money into your investment, you are taking out from your account and giving to somebody. That is outflow. It's going out of your account. When you receive money, it's going into your account. So all these are inflows. Okay. So NPV is cash inflow. Okay. How do we get this formula? Okay. We are using the compound interest formula. Okay. This is 1 plus R to the power of N. P here is the present value. So P is actually S over 1 plus R to the power of N. So if your if your S, that means your future value at year 1, if it's CF1, then this is CF1 over 1 plus R. If it's year 1, then it's the power of 1. Okay. So that is how we get this formula. This is for year 2 and so on. So if the project is for 5 years, you must calculate 5 values of present value. If the project is for 10 years, then you must calculate 10 values of present value. Okay. Once you have calculated, changed all the cash inflows into present value. So we have changed, this formula is changing it into the present value. Once you have changed all into the present value, you add everything and you minus your initial deposit. XO is your initial payment. Okay. So this is the formula to calculate NPV. Okay, CF is the cash flow expected for each period. R is the required rate of interest, also known as the discount rate. This is normally given. Okay, the discount rate or the required rate of interest is given. XO is the cash value in time 0. It's also the initial project investment. Okay, sometimes if you're buying buying something or paying for something, that is the initial project investment. Okay, so this is the formula for NPV. Let's do an example. Okay, you want to calculate the net present value. Say a company can invest in a project with a life of 5 years. That means this project is only going to last for 5 years. Okay, the projected cash flows are shown below here. Okay, these are the projected cash flows. Discount rate given is 10%. Okay, discount rate given is 10%. The cost of capital per annum is 10%. Either sometimes they will tell you discount rate is 10%, or sometimes they will write as the cost of capital per annum. It means the same. Okay, these two is the same. I've just written it in a different way so you will understand that. Okay, so now they're asking you, should you make this investment? So you want to find out whether this investment is worth your money or not. Okay, so how much from this table, this is called a cash flow model. Okay, so this cash flow model is already given to you. This is year 0, 1, 2, 3, 4, 5. The life of this project is 5 years. Okay, when they write a negative like this, it means money going out. This means it is outflow. Okay, positive, or if they don't write anything, it means inflow. Okay, that means how much is your investment? How much is your initial investment? How much did you put into the project?
10,000.
How much?
10,000.
Okay, when do you put into the project? At time, which time? At time
Year 0.
0, yes. You put the money into the project at time 0. So how much did you put into the project at time 0? 30,000, right?
30,000.
Yes. So
Yeah.
this is your investment. Your investment is always at time 0. And usually there must be a negative. Or either they give you like this, or they will tell you, you invested 30,000. You invested 30,000. Or if they give you in the cash flow model, they will put a negative. This negative represents outflow. That means you are paying out. Okay, you're paying out the money. This is cash outflow. This is your investment. Okay, and then after you put in 30,000 into the project, every year from that moment onwards, every year you get 10,000. So how much have you got after 5 years?
40,000.
Why 40? Why 40? What happened to one more
50,000
10,000?
later.
50, right? Okay.
Yeah.
Okay. So say you have 30,000 now, and your friend comes and tells you, oh, I've got a wonderful project. If you put in your money, you can get back a lot of money. Every year, I'm giving you 10,000. You put in 30,000 today. Every year, I give you 10,000 for 5 years. Will you deposit your money? Yes, isn't it? Isn't it?
Yes.
Because 10,000 per year, you get 50,000. You put in 30,000, but you get 50,000. So not straight away, people might think, oh, I get 50,000, I'm getting 20,000 more. So you are inclined to think that you are getting a profit. So that is wrong. Okay. So we must calculate to the present value. Okay. Now we're going to calculate and see whether this is worth it or not. Okay. Okay, so we're going to calculate the present value of each cash flow. What does that mean? That means from here, we are going to calculate and see how much is this worth here. This one, how much is the present value worth here? This one, we must calculate to here. Okay, each one we're going to calculate and see how much is each of these cash flow worth today. Okay, so let's do the first one first. Okay, present value of cash flow 1. Say this is CF1, this is CF2, CF3, CF4, CF5. Okay, so cash flow 1 is CF1 over 1 plus R to the power of 1. N is 1, is year 1. Okay, so the future value of CF1 is 10,000. So we substitute for 10,000. Our discount rate is 10%, which is 0.1. So 1 plus 0.1 to the power of 1. Calculate, you get 9,090. So this is the present value. That means in 1 year's time, you are getting 10,000. But today, that money is only worth 9,090 ringgit and 91 cent. Okay. Okay, then we have to calculate one by one. Then we have to calculate the cash flow for CF2. Okay, so CF2, okay, is 10,000 over 1 plus 0.1 to the power of 2 here, 2 years. Okay, how much is CF2? 8,264 and 46. Then we calculate the present value of cash flow 3. Cash flow 3. Okay. So we get here. So we have 10,000 over 1 plus 0.1 to the power of 3. The cash flows are all the same. They are all 10,000. So we calculate this, okay? And then we calculate cash flow 4 and we get this much of money. So altogether, how many cash flows do we have?
5.
5. Okay, so we have calculated cash flow 5. Now what do we do?
Subtract. Add together.
Yes, add together. So now you have calculated the present value for each of the cash flows. Now you add all together first, okay? So the total present value of cash flows, 1, 2, 3, 4, 5. Add it all together and you get 37,000. So you see just now when you added, we got 10,000 every year for 5 years, it's 50,000. It looks like we're getting 50,000, but actually it's only worth 37,907 ringgit and 86 cent. Now we have to find the net present value. Okay, net nilai bersih. Okay, we have to find the net present value. So what is this? This is the total cash inflows. Okay, or we just say cash flows. Okay, minus the cash outflow or initial investment. Okay, minus the cash outflow or initial investment, so that you get 37,907.86 cents minus 30,000, so you get 7,907 ringgit and 86 cents. So now, should you invest in this project?
Yes.
Why?
Because the net present value is more than 0.
Yes, the net present value is positive, more than zero. Even if it's a small amount like this, like 9 ringgit and 80 cents, even this is also okay to invest as long as it's positive, okay? So it's okay to invest. So therefore, this project is worth investing in, okay? Since the net present value is positive, investment in the project can be made. That means you put in 30,000, you are actually getting back 37,907 ringgit and 86 cents now, today, present value, okay? So that means it's okay to put. In other words, this investment is worth it because there's a profit, okay? The value of this investment is worth 37,907 ringgit today. This means that any initial investment up to this will be worth it. Even if you invest 32,000, it will be worth it. If you invest 35,000, also will be worth it. If you invest 37,000, also will be worth it. Any investment up to this amount will be worth it. Okay. So by paying this price, the investor will receive 10,000 every year for 5 years at a rate of return of 10%. If your investment is exactly this amount, okay, if you make an investment exactly this amount, then your IRR is exactly 10%. You understand why? Because
NPV is zero.
yes, if your investment is exactly this amount, your investment, your cash flows is also this amount. So your cash flow minus the investment is zero. Okay. And when that is zero, the discount rate at that moment is your IRR. And because your discount rate for this project is 10, okay, if your investment is this amount, then your IRR is 10%. Okay. So if the investment is less than this amount, then your IRR is more than 10%. Okay. If your IRR is more than 10%, then this project is very worth it. Okay. For this project, the discount rate is 10%. If you calculate the IRR and it is equal to 10% or it is more than 10%, then the project can be accepted. Okay. But if your IRR is less than 10%, then don't accept it. Okay. Okay, example 2, calculate the net present value. You have been asked to invest 1,000 in a project that pays 600, 400 and 200 in the third year. Okay, first year 600, second year 400, third year 200. So how much do you get all in all in future?
1,200.
Yes, so 1,200. So now you want to know whether it is worth it or not to get the 1,200. Okay, so they told you that the discount rate is 8%. So is this investment worth it? So what do we do first? Let's draw the cash flow model. Okay, so this is year 0. You are investing 10,000. So you can write like this, negative RM 10,000, or you can put in bracket like this, RM 1,000. Okay, 1,000 in bracket. It means cash outflow, going out. Negative means going out. Okay, so this is 600 first year, second year you will get 400, third year you will get 200. So now what must you do? You must find the present value of 600. You must find the present value of 400 and you must find the present value of 200. Okay, so find the present value of 600. Discount rate is 8%, which is 0.8 first year. So this is to the power of 1 and you get that much. Okay, then you find the present value for the second cash flow, 400. Discount
Madam,
rate, yes,
8%, right?
8% is 8%.
Is it supposed to be 0.08?
Yeah, 0.08. Yeah, 0.08. Yes, I made a mistake. Wait, let me go back and see this one. Yeah. Okay, I made a mistake in the calculation, okay? So my calculation is a little bit out already, okay? So never mind, we'll just overlook that for a while for the sake of just learning the method, okay? So we calculate the present value of cash flow 1, cash flow 2, and cash flow 3, then add it all together, okay? Here we have added straight. You can do it straight, or you can just add this together and then minus the 1000, or straight away you add negative 1000, okay? So whichever way you can do it, yeah? Okay, so you get negative. Say the answer is negative now. So this is your NPV, net present value. Now, do we accept the project or we don't accept the project? We don't, right?
No.
Because the net present value is negative. If it's negative, the investment in the project is not worth it. Okay? So it must be positive, you accept. Anything negative, don't accept it. Negative means what you're putting in is more than what you're getting. So what's the point? Isn't it? So what's the point of investing? So don't invest. Right? Okay? If there are two investments that have positive NPVs and the investments are mutually exclusive, meaning only one can be chosen, the more profitable of the two investments is the more appropriate to be chosen. That means if you have two investments, okay, you're considering between two investments and both have positive NPVs, then which will you choose? The one that has a higher amount. The higher amount is more profitable. So choose that. Okay. Okay, this is for NPV. Okay. Now we go on to calculate IRR. Okay. The IRR can be stated in the form of a ratio as shown below. This is correct, right? Cash inflows. In other words, this means that cash inflows is equals to cash outflows, correct?
Yes.
This also means that cash inflows minus cash outflows is equals to 0.
0.
Yes, this is what IRR means, okay? That the NPV, this is NPV, okay? Cash inflows minus cash outflows is NPV, the net present value, okay? That means the NPV is 0. Find the discount rate when NPV is 0, okay? In other words, the present value of cash inflows minus the present value of cash outflows equals to 0, okay? So for IRR, okay? You remember many times we have tried to find the interest and the only way to do it was to use trial and error. So this is how we're going to do also. Using guess and check or trial and error method is the common way to find IRR. Or you can use the formula in Excel. In Excel, they have the formula IRR. So you just have to use that formula to calculate. Okay? But if you're doing manually, then you have to use guess and check. Okay, to calculate IRR, this is the formula that we are going to use, okay? CF0 is the cash outflow or the initial investment. This is equal to the total of all the cash inflows. Okay, so now you don't know the discount rate. This is what you want to find, the rate of return, IRR. You want to find this, okay? So we don't know this value. So that is why the calculation is more difficult. We want to find that value. Okay. To find IRR using the present value tables. Okay. Okay. There is one method that we can use to estimate the IRR before we use the guess and check. Okay. We can use the present value factor tables. Okay. For this, we need to know the cash flow number of return periods and the present value factor. To calculate the present value factor, we use the following formula, okay? F equals to I over C. F is the present value factor, I is the original investment, and C is the average cash inflow per year. Average, average cash inflow per year. Okay. Okay, we find the present value factor in the present value table, okay, in the row with the corresponding number of periods, okay. Okay, this I won't explain this first. I'll show you how to do later, okay. Okay, say we want to do this question. We want to invest in a project with an initial investment of 10,000. Okay, so initial investment is 10,000. The project is expected to generate 5,000 in the first year. Okay, CF1 is 5,000, CF2 6,000, CF3 7,000. So you want to know if this project is worth it or not, whether you should invest in it. So you're going to calculate the internal rate of return. We are using this method instead of the NPV, okay? So to use this method, this is the formula that we are going to use, okay? So this is our initial investment, 10,000. Cash flow 1 is 5,000 over 1 plus, we don't know the discount rate, okay? To the power of 1, cash flow 2, cash flow 3. Only 3 cash flows, so we only need to add 3 cash flows only, okay? To find IRR using the present value tables, we need to know the cash flow number of return periods N. Here, N, our N is 3, okay? And the intersecting present value factor. So now we have to calculate the present value factor using the formula just now. F is equals to I over N, okay? So we want to calculate this factor here, present value factor. Is the initial investment cost. What is our initial investment cost?
$10,000.
Okay.
10,000.
What do you think is our annual average net cash flows? Average cash flows. What's our average cash flows? 5,000 plus 6,000 plus 7,000 divided by 3 is 5,000 plus 6,000 plus 7,000 is 18,000, right? Divided by 3 is 6,000. So we have 1.6667. Okay, 1.6667. So now we know that the number of return period is 3. Okay, the project's life is 3 years. So the number of return periods is 3. Okay, so now we want to find the present value factor from the table in the row corresponding to 3. 3 years, so 3. Then we find the matching interest rate. Okay, how do we do that? Okay, now we have to look at the table. Okay, we need to look at this table. Okay, so how many years was that just now? 3, yeah? So we look at 3. And what was the value just now? Our present value factor was
1.667.
6667, okay? So we look along row 3, okay? Along row 3, because the time period is 3 years. So we look and search for 1.6667. Can you see that? Okay, you tell me, what is the corresponding percentage? Anybody?
36.
36, huh? Okay. Here we are at 1 point, this one here. Here we are at 1.6516. We want 1.6667 around here. So it's actually between 36 and 30. This is a little bit more already, 36, huh? Isn't it? So it's actually between what? It's between 36 and 37. So we know that the percentage is between 36 and 37. So now what do we have to do? We have to use guess and check. Okay, so now from the table we know that it's between 36% and 37% already. After this, we have to use guess and check. If you don't know this, then it's very hard to use guess and check, right? You don't know where to start from. If you're going to start from 1, Imagine you have to go very slowly, okay? So now that you know it's around here, but even if it's around here, it can differ by at least 3 to 4%, okay? It can differ by that much, lah. Okay? So from here, you have to substitute the IRR in the formula until you get NPV is equals to 0. That means you replace this IRR. Say you replace this with 36%. You start with 36%. 36% is 0.36, correct? So you replace IRR here with 1 plus 0.36 to the power of 3. Here is 1 plus 0.36 to the power of 2. Okay, 1 plus 36 to the power of 1. And you calculate and see if your right hand side and the left hand side is the same. Okay, that means you must get 10,000. The whole thing must give you 10,000. If you don't get, then you look at the value and you increase or decrease until you find the answer. Sorry. So your IRR is 33.87. This is the answer. Can you understand that? The table I've given you in your classroom, huh? Okay. But the other easier way is to use Excel. Okay. Use Excel, you can get your formula, your answer much easier. Okay. If you want to do manually, then this is how you should do manually. Okay. You must calculate the present value factor. This is average. Huh?
Madam,
Yes.
Why the IRR not between 36% and 37%?
Yes. So.
Isn't 36 and 37% we will get around the number?
Oh, you're asking me why is this answer not in this range? Huh? Yes, like I told you just now, your estimate is around here, but when you do the actual calculation, it can run by 3 to 4%. Okay, it can run that around that much. It won't run too much, but around that much, 3 to 4%, lesser or more. It can be like that. So the only way you will know is by substituting and calculating, guess and check. That's the only way you'll know, lah. Okay.
Okay, thank you, madam.
Okay. So when you want to find whether or not to invest in a company project, there are two methods that you can use. One is NPV and the second method is IRR. If they don't tell you which method to use, of course, it is so much easier to use NPV and it is the better method. If they insist that you use both, then you must use both. Must use both and you must show that your decision must be based on both the values. Sometimes it's easy to make the decision because both will be high. If the NPV is positive, IRR will be high. So definitely you accept. But sometimes you will get different opposite results. Okay. In that case, when that happens, you have to look at the whole question carefully. Okay. 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 Sorry. Okay, this question is actually a tutorial question. Okay, I won't do it now. Okay. Okay, the advantages of using NPV method over IRR using the above example is that NPV can handle multiple discount rates without any problem. Okay, each year's cash flow can be discounted separately from the others. This means that they tell you year one, here there's one discount rate, okay, and then here to here there's another discount rate. So with NPV, it doesn't matter if the discount rate is different, you still can calculate using the formula. But with IRR, you cannot do that. It must be a same discount rate. So that's why NPV is a better method. Okay,